Hi, if you're watching this in the classroom, I hope I'm there with you because this is an exciting topic for linear algebra, linear transformations, and I hope I get to share it with you. If I'm not there with you, then you know that I'm busy doing other things that I also love doing, but I miss teaching you. Teaching to the camera is different from teaching in person, and so learning on your part will be different also. I will do my best to not repeat things onto the camera. That means that the clips will be as short as possible, and that's a good thing, but that also means that you need to pause the video when you've missed something, go back to rewatch things that you've missed. You will probably have to watch this video or these videos multiple times, just like reading a book. If you were to listen to a math on an audio book, that would probably not work very well for most people. You would have to pause and go back, because when you read math, you don't read from top of the page to the bottom of the page and then you're done. When you read math, you always have to go back and reread, and it's a slow process to read math. So this handout is 7 pages. You should print the handout before watching the videos, and that way you can take notes on your handout just like you would in a book. And in fact, these videos will sometimes tell you what would be some good examples of notes to take. For using that, or in order to do that, I'll be using this whiteboard. So I can write some things on this whiteboard that don't typeset very well in the handout. The handout is like pages from a book, but the talking on the videos, I can do things on a whiteboard a little bit. So you should especially draw pictures. So now, here is the structure of the handout. This handout represents about 3 days worth of class, a week of class. So far in Chapter 2, we've learned linear spaces, also known as vector spaces. So those are sets, mathematical sets, that satisfy the linear properties. Remember, there were 10 axioms that described everything that we normally think of when we think of linear can be captured in those 10 axioms. And so we were studying linear spaces. We shift now to the second half of Chapter 2. A lot of courses would actually have this as a separate chapter instead of combined with Chapter 2. We are now shifting away from linear spaces. We'll still be using all that stuff. We're building on it. But now the topic will be what we call linear transformations. And so the first few pages of this handout, definitions and examples, these are meant to introduce this new topic called linear transformations. Just like linear spaces or vector spaces was an abstract topic, linear transformations are an abstract topic. However, by the time we got to the end of the linear spaces section, by the end of 2.3, we had this fundamental theorem, what I like to call a fundamental theorem of vector spaces, which is that any vector space, or any vector in a vector space, can be represented uniquely in terms of a basis set, or as a linear combination of basis objects. And while the basis set itself is not unique, we can find many different basis sets for any given vector space. The size of that basis set, or other words, the dimension, that is unique. And so we got to finally the end of the theory and found a nice concrete way to represent this abstract concept of vectors. A vector could be represented as a sequence of coordinates. We'll do the same thing with the abstract topic of linear transformations, and in fact we'll be building on that concept of basis. Just like vectors could be represented as a sequence of coordinates, that's kind of like listing the numbers as in Rn, we can represent linear transformations as an array of coordinates, a 2D array, also known as a matrix, or in Rm by n. And so the second part of this handout would be representing linear transformations as matrices. The last part of this handout ties chapter 2 together. Most books have separate chapters for vector spaces and linear transformations, but this last part of the handout does tie everything from chapter 2 together. And that is, when we have a linear transformation, it naturally defines certain subspaces. And some of these kinds of concepts we've actually been using, and we're finally going to put some names on them and formalize them at the end of this handout. And then that will serve as a good introduction to what our book calls the fundamental theorem of linear algebra. I like to call it the fundamental theorem of linear transformations. We won't get to the whole fundamental theorem of linear transformations, though, until we've seen some geometry in chapter 3.